All right, Math 2. Last video for the remediation, and it's on rectangles. So a rectangle you have to understand is a parallelogram also. So all the properties of a parallelogram will exist in a rectangle. But in addition, what you guys have to know and understand is by definition of a rectangle, that all four angles are right angles, opposite sides are congruent, all right? But a couple of things I want to talk about here is when I have this diagonal drawn here, and then I draw another diagonal here, okay? One thing we're going to say about this is diagonals bisect each other, right? But then they're also congruent. So what happens here is if these are congruent and these are congruent, but then the diagonals are all congruent, that means all four pieces of the diagonal are equal. Why is that important to know? Because what I like to do is look at this as each of these triangles inside are their own. So like these two triangles are congruent, right? Isosceles triangles. And then these green ones are congruent isosceles triangles. And that helps you answer or find missing information in a lot of rectangles. So let's apply these properties real quickly. So example 1, find the length of the diagonals of a rectangle if FD is 2y plus 4 and GE is 6y minus 5. So whenever we are given rectangle GFED, we're going to start at one vertex and you're going to go around clockwise or counterclockwise. Now they're telling me FD is 2y plus 4 and then GE is 6y minus 5. Well, what do we know about the diagonals of a rectangle? They are congruent. So we know FD is congruent to GE. So what do we do with their measures? We set them equal to each other. 2y plus 4 equals 6y minus 5. And now, when we go ahead and solve, subtract, so we get negative 4y equals negative 9. So y is equal to, divide by 4, and you get 2.5. Now, if y is 2.5, to find the length of the diagonals, you know FD equals GE, so we just pick one of these to plug 2.5 into. So 2 times 2.5 plus 4, this gives you 5 plus 4, which gives you both diagonals have a length of 9 units. Okay? Number 2, they tell you DEA is 35 degrees. So if I trace it, DEA, this is 35 degrees. Now, before I start filling out any of these angles, the first thing I do is use all of these angles in the middle by saying these are vertical angles, so that's 35. These are a linear pair, so 180 minus 35 would give me 145, which means by vertical angles, that's 145. Now, if you remember what I said, if you think about this as all of these are isosceles triangles, what you have to know is these angles are going to be congruent. These angles are going to be congruent. These angles are congruent to each other. These angles are congruent to each other. Because if sides of an isosceles triangle are congruent, then angles are congruent. So how do I find an angle like this? Well, what do all three of these angles have to add up to? 180. So I'm going to do 180 minus 35, and that's going to give me 145. But if these two angles are congruent, right, I'm going to divide that by 2, and this angle would be 72.5. This angle would be 72.5. What you have to know is all of these angles will be 72.5. Now, when I go to find these other angles, this angle here and this angle here, two ways you can do it. You can do the same thing. You can do 180 minus 145, which gives you 35, and you can divide that by 2 to get those. But to me, what do these two angles have to add up to? 90 degrees, right? So what is 90 minus 72.5? Well, that'll give you 17.5, which makes this 17.5, which makes this 17.5 and this. Now I could just come over here and trace the angles. AED we said is 35 degrees. ECD we have marked as 17.5. So remember, this angle here is this angle here. Then EAB, so if I trace EAB, that's that angle, which would be 17.5. Now EDC, 17.5, and then angle good old AID is 17.5. EDA is 72.5. EBC is 72.5. And BCE is 72.5. So being able to trace them after you fill them all out is important. So the next one is a square. Now remember, a square is every parallelogram we've talked about. It's a parallelogram, it's a rectangle, and it's a rhombus. So it holds all of those properties. Now it says find the measure of angle ABC, ADC, DAC, and ACB. Right away we know this angle and this angle are right angles. Now we know this is a right angle, but what you have to understand is if it's 90 degrees, because of the property of a rhombus, is diagonals bisect opposite angles. I know those are congruent, and I know these are congruent, which makes all four of them congruent. So if I take 90 and I divide it by 2, this is 45, this is 45, 45, and 45. So angle ABC, that's pretty easy. That's just 90 degrees. ADC, again, easy, 90 degrees. But DAC is 45 and ACB is 45. Okay, example 4. AE, they tell us, is 2x. Then they tell us DB, this here, this whole thing, is 24. Remember, right, with this, you have to understand that the diagonals are congruent because it's a rectangle, and because it's a parallelogram, these bisect each other. So right away, if this whole segment, DB, is 24, and I know AC is also 24, if I take 24 divided by 2, this piece is 12, this piece is 12. So to find x, 2x equals 12, x equals 6. Now, if I'm going to find it, remember these are all 90 degrees, and because it's a rhombus, all of these angles are bisected. So all of these angles are 45 degrees. But in the middle, because it's a rhombus, right, I know the diagonals are perpendicular to each other. So ACB is 45. AED is going to be 90. BEC is 90. And BCA would be 45. Okay, so go ahead and try the rectangle assignment, and if you have any questions, let me know.